Hello, today we will be discussing development throughout the lifespan. And to begin with, we consider the belief that adolescence is always characterized by turmoil. And definitely when you think back to your prime teenage years living under your parents' household, you may have experienced an increase in the number of arguments that you had between you and your parents or you and your siblings. But often these teenagers or teenagers in general are stereotyped as troubled youth that are trying to gain some type of independence. They're always arguing with authority and experience high moods and low moods within a short time span. So although we know these characteristics are often true of adolescents, research has demonstrated that 80% of youth report a happy adolescent period. And interestingly, we often see the stereotypical teenage years more so in Western cultures, which points to the influence of culture on our development. And the study of development across the lifespan is developmental psychology. And so development includes transformations in the way we look, think, feel, and act. And these changes span the lifespan or span our entire lifespan and includes infancy, childhood, adolescence, and adulthood. Before we start our discussion of each period in our development, the chapter discusses what occurs following conception prenatally within the womb. And so the prenatal period is split up into 3 stages involving the germinal state, the embryonic stage, and the fetal stage. And during conception, 200 of the original 200 million sperm find the correct fallopian tube and get close enough to an egg to release a type of enzyme that is essentially like a digestive enzyme that erodes the egg's protective outer layer. The sperm then penetrates the egg or the coating, and the egg quickly releases a chemical to seal the coating and keeps all remaining sperm from entering. And from there, the sperm sheds its tail and fertilizes the egg. Within 12 hours, the nuclei of the sperm and the egg merge together, and the prenatal development of humans begins. And the germinal stage of development occurs during the 2 weeks following conception, and it involves the zygote, which determines gender, and each human sperm cell and each human egg cell contains 23 chromosomes that contains these genes. And so the 23rd chromosome is either X for female or Y for male. The male sperm determines the sex of the zygote. So this is basic knowledge that you gain from your intro to bio class, but more so talking about the zygote begins to divide into 2 cells, then 4, and then 8, and so on and so forth. And by birth, the zygote has divided into trillions of cells, each containing 23 chromosomes from the egg and 23 from the sperm. The zygote migrates down the fallopian tube and implants itself into the wall of the uterus. This is a difficult journey where about half of zygotes do not make it because either the zygote is defective or it implants itself on an inhospitable part of the uterus. So we move on to the next stage. During the embryonic stage of development, the zygote becomes an embryo which continues to divide and its cells begin to differentiate. And by this point, it's only an inch long, but it has a heartbeat, arms, and legs. Embryos who have an X and one Y chromosome then begin to produce testosterone. The fetal stage of development involves the now fetus developing the ability to move. And also during this time, the fetus increases rapidly in size during the last 3 months of the fetal stage. And while in the womb, the fetus can hear and learn. So they can hear their mother's heartbeat, her gastrointestinal sounds that are associated with her digestion, and even learn her voice. Here we see snapshots of each stage, within the prenatal period of development. The first picture is of a zygote during the germinal stage, which begins after we discussed occurs after conception and lasts for 2 weeks. The second picture is of an embryo, and this stage occurs during the 2nd week of life and lasts until the 8th week. Lastly, the fetal stage of prenatal development occurs 9 weeks following conception and lasts until birth. So it's natural to assume that genes influence the fetus's development from a moment of conception and that the environment influences the infant's development from the moment of birth, but this is not the case. So foods and substances that the mother intakes during the pregnancy can also affect development within the womb and following birth. So the womb influences development in a multitude of ways. The placenta, for example, allows for the exchange of material good, whether that's good or bad, between mom and baby. And research has found that children of mothers receiving insufficient nutrition tend to have physical and psychological problems later in life, such as an increased risk for developing schizophrenia or antisocial personality disorder. Foods that mom eats also shapes the child's food preferences, as demonstrated by infants tending to prefer foods or spices that the mom ate while they were in utero. The prenatal environment extends beyond just more than food preferences, so anything the mother eats, drinks, inhales, injects can pass through the placenta onto the fetus. And these may be known as teratogens. And so teratogens are environmental poisons. For example, lead in water, paint dust in the air, mercury in fish. The most common teratogen, although, is alcohol. And so fetal alcohol syndrome, or FAS, occurs when the mother ingests alcohol. So children with FAS have distinct facial features. They may be born with brain abnormalities, and they have cognitive deficits. So significantly, one thing to know about FAS and the teratogen that we know as alcohol is that there's no medical consensus regarding a safe amount of light drinking. So whether that's 1 drink or 10 drinks during pregnancy, there is no medical consensus of how much drinking will cause a child to be born with FAS. Tobacco is also a common teratogen, resulting in lower birth rate, weights and likely perceptual and attentional problems in childhood, even just from secondhand smoke. And the embryo is more vulnerable than the fetus to smoking, but the central nervous system remains vulnerable throughout the entire prenatal period. Researchers estimate that if all pregnant women in the U.S. would quit smoking, there would be an 11% reduction in stillbirths and a 5% reduction in newborn births. Here we have an example of facial characteristics of a child born with fetal alcohol syndrome. As we can see from the picture, there is a lack of a ridge under the nose, a thin upper lip, short eye openings, and a flat mid-face. Following the prenatal stage, we know that the next stage, we're kind of shifting gears here, but the next period of development is infancy, and we'll discuss this in the next few slides. So infancy begins at birth and lasts between 18 and 24 months. What infants can see typically during this stage is they can see 20 feet equal to what we can see at about 600 feet or 2 football fields. So their vision is better up close, and newborns will respond to visual stimuli like a new toy, but are even more responsive to social stimuli. So one example is their ability to mimic facial expressions even within the first hour of life. Alternatively, newborn animals imprint on their parents as opposed to mimicking their facial expressions. So we'll talk more about imprinting later in the chapter. Infants use their eyes right away, but spend considerably more time learning how to use most of their other body parts. So, evolutionary speaking, vision for infants is not as important as developing their motor ability, let's say. And so during infancy, infants begin to develop their motor skills. And motor skills include reaching, grasping, crawling, and walking eventually. So we're all born with a small set of reflexes, which include the rooting reflex. So you may observe the rooting reflex when infants move their mouth towards you when you stroke their cheek. So this is a natural reflex for any child and is adaptive for them for nursing. And so the second reflex is the sucking reflex, and this is where they experience the environment by sticking everything in their mouth. And both of these reflexes allow newborns to nurse, which we know is important for infant survival. However, these reflexes, which are present at birth, disappear in the first few months after children learn more sophisticated behaviors. The development of more sophisticated behaviors tend to obey two rules. And the first rule includes the cephalocaudal or top to bottom rule. And infants gain control over their head first, then their arms and trunk, then their legs. So this is why when we place an infant on their stomach, they may be able to lift their head, but typically they have little control over their legs. So the second rule is proximodistal, and this rule follows an inside to outside rule, where infants learn to control their trunk before their elbows and knees, and they can control their elbows and knees before they can control their hands and feet, and so on. So the timing of this development depends on many factors, such as the baby's incentive, like if they have mobiles or toys around them that help to encourage their movement, their body weight, their muscular development, and general level of activity also influence infants' motor development. And so we end our first lecture with a graphic of an infant's timeline of motor development, starting with the ability to lift their head all the way down to walking their first steps unassisted by an adult. And so this illustration is a great resource and quick read for memorizing the timeline of infants' motor development. And so with that, that wraps up the first section of Chapter 11 and development.